Okay, let's take a look at these and see how you did. So the first one, this is addition, so we can just do our number line. From 0, we go to negative 27. Positive 49 goes the opposite direction, and it's longer, so it takes us past 0, telling us that that is going to be positive. And since the vectors go opposite directions, it's the difference in their length. So 49 minus 27 would be 22. So that is a positive 22. Any questions on that one? Okay. So the next one here, negative 53 minus 32. Remember, we changed subtraction to adding the opposite. So that'll be negative 53 plus negative 32. So then we have negative 53 and negative 32 both go in the same direction. So we're on the negative side of 0. And since they go in the same direction, we add their absolute values. 53 plus 32 is 85. So negative 85 is our result. Multiplication and division is actually a little bit simpler. We do the operation, and then we worry about what sign it has to be. 9 times 7 is 63. A negative times a positive is a negative. And for number 4, negative 48 divided by negative 4. Well, a negative divided by a negative will be positive. 48 divided by 4 is 12. Positive 12, or just 12. Any questions on those? Okay. Now, if you're going to use your calculator to do the integers, you cannot, most of your calculators, you cannot use the subtraction key to enter the negative. Some of your calculators will allow you to do that, and sometimes it only allows you to do it in certain times or certain situations. Most of your calculators have a negative key that looks like this. It's down by your equals key, or your enter key, and that's what you would have to use to enter your negative. So, as an example, number 4 up here, you would press that negative key, type in 48, divided by, press that negative key again, and then 4 and hit equals, and it should give you the answer of 12. Some of you, again, I don't know what calculators all of you have, but some of you, if you have a one-line display calculator, might have a key that looks something like this. It's called the swap sign key. It actually will make it negative, but it works just slightly different. You have to press that key after you enter the number to make it negative. So you would have to type in the 48 and then press that key to make it negative, divided by, enter the 4 and press that key again to make it negative. And it'll give you the 12. Most of you most likely have the top option. They don't make too many of the older style calculators with the swap sign key. I'm not going to go over using the calculator any more than just that. So if you have any questions on yours, please feel free to talk to me and I'll go over it with you one-on-one. Just because everybody's calculator is slightly different, and I don't want to take class time to go over every type. As we go through stuff, you'll learn that calculator does amazing things. Now, we left off yesterday. We had started talking about order of operations. And we had done some simple examples, ones that looked like this. Some simple examples. Now remember, what is our highest level of priority when we do order of operations? Parentheses or enclosing symbols. So far, all we've seen for enclosing symbols are parentheses. And when we have more than one, we go left to right. So going left to right, this is the first one we see here between the 2 and the 7. So now what we need to do with that is find its other end. Is this one its other end? No, that's facing the wrong way. How about this one? Nope, that goes back to here. So you go all the way down to here to find the other end of it. So we start with this problem inside that set of parentheses, inside the brown box. Now somebody might be thinking, but we've got to go into the other one. We do. Inside that parentheses, inside that enclosing symbol, the order of operations still applies. And we still start from the top of the level of priorities. So inside that brown box, are there any other enclosing symbols? There's another parenthesis, right? So now we move inside to that parentheses, inside the green box. So we start inside there. And again, the order of operations still applies in there. Any other enclosing symbols? No. Any exponents? No. So multiplication and division? Yes, we have the division. 12 divided by 2, which is 6. So I replace the 12 divided by 2 with 6. Everything else in this problem is going to stay exactly the same. Now we're still working inside that parentheses. All that's left is 8 minus 6, which is 2. So replace 8 minus 6 with 2. Everything else stays exactly the same. Now we have reduced what was inside that enclosing symbol, in this case what's inside the parentheses, to a single number, which means we don't need the parentheses anymore. When we remove an enclosing symbol, there are 2 things we always have to worry about. The first is that enclosing symbol telling us we have to do anything? Now parentheses doesn't. We do everything inside the parentheses, but the parentheses itself does not perform an operation. Absolute value symbols, those are enclosing symbols. When we remove those, we have to do something. And some of our other enclosing symbols, when we remove them, we have to do something. A parentheses, we do not. The second thing we have to worry about when we remove an enclosing symbol is, are there any implied operations? And here there is. We have that 3 in front of the parentheses with no operation there. What is implied? Multiplication. Good. So when we remove those parentheses, we have to put in that multiplication. It is 3 times the contents of the parentheses. In this case, 3 times 2. So now those parentheses are gone. They are finished. We move out to the larger set of parentheses. So we're going to work in there. Now in there, our order of operations still applies. We wiped out that first parentheses, but are there any other enclosing symbols? No. Exponents. Yes, we have 3 to the power of 2, or 3 squared. We haven't talked really about exponents yet, but 3 squared is, careful, 3 squared means 3 times 3, 9. So replace 3 squared with 9. Everything else in the problem stays the same. Now, inside that parentheses, any other exponents? No, so we move down the list. Multiplication and division. There's actually a couple of multiplications, so we will go left to right. First one we'll see is 3 times 2, which is 6. So replace that 3 times 2 with 6. Everything else stays exactly the same. Now we still have more multiplications in there. We have 5 times 3, which is 15. Again, we replace the 5 times 3 with 15. Everything else stays the same. No more multiplication or division. So we're down to addition and subtraction. There's several of them, so we are going to go left to right. 7 minus 6 is 1. Replace the 7 minus 6 with 1, and everything else remains. And then 1 plus 15, which is 16. So we replace that. And now all that's left in there is 16 minus 9, which is 7. So now once again, we've reduced what's inside an enclosing symbol to a single number. So we don't need the parentheses anymore. When we take them out, again, parentheses don't imply that we do anything to the number inside of it. But we do again have that implied operation of multiplication. It's 2 times 7. So now we're done in that parentheses. We're back out to the larger problem, and we go through our levels again. Any enclosing symbols? No. Exponents? No. Multiplication or division? Yes. So we go left to right again. 2 times 7 is 14. Next would be 3 times 4, which is 12. No more multiplication or division, so we're down to addition and subtraction. Go left to right. So we have 9 plus 14 is 23. 23 plus 12 is 35. So as long as you're very careful and follow the steps, every step, you're replacing 2 numbers with 1. Everything else stays the same. Where people get themselves in trouble with these problems is they want to save time and paper, and they try to do 2 steps at once. And sometimes it's okay. Sometimes it works. Sometimes it does not. Like, for example, up here, it would be really tempting to try to do the 2 times 7 and the 3 times 4 all in the same step. Then you get 9 plus 14 plus 12. There's a case where that would be okay. You could do it. But there are other cases where trying to do something like that is going to cause problems. The biggest mistake students will make on this problem comes really before you even start. It's that huge temptation. Students want to look at this and say, oh, 9 plus 2 is 11. I'll do that first. Why can't I do that? Yeah. We had mentioned yesterday that those levels of priority can either apply to the whole problem or they can apply to an individual number. Now, if you're applying them to the whole problem, they automatically get applied to the individual numbers. But if I were just focusing in on this 2 here, the 2 has an operation on each side of it. In front of it, of course, is the addition. After it, it's implied that that's multiplication. Which one has priority? The multiplication. So we cannot do anything with that addition until we have completed the multiplication on that 2. So you cannot add the 9 and the 2. It's really tempting. It's up there up front all by itself. And I usually catch at least 1 or 2 people doing that on a test. So be careful. You got to follow those levels of priority. Now we've mentioned that there are other enclosing symbols out there. It's time to take a look at some of them. One might look like this. Looking at this, do you see any enclosing symbols? The square root. An enclosing symbol is anything that separates some of the operations in the problem from the rest. And that square root does. We've got addition and multiplication inside there. So it's telling us that we have to do what's inside there first. Now inside there, our order of operations does still apply. Any other enclosing symbols? Nope. Any exponents? Nope. Multiplication and division. Yeah. We have 9 times 7, which is 63. We replace the 9 times 7, and everything else stays the same. The last thing left in the parentheses is to add 1 plus 63, which is 64. Did I say parentheses? Last thing left inside the square root, I should say. Now we've reduced what's inside that enclosing symbol, in this case the square root symbol, to a single number. Just like with parentheses, we can now remove the enclosing symbol. But remember, we said when you remove an enclosing symbol, the first thing you have to ask, is it telling us to do something? And the square root is. It's telling us we have to take the square root of that number. What is the square root of 64? 8 is the square root of 64. Technically, when we learn more about square roots, it'll be 8 or negative 8, but we're going to go with just 8 for now. So when we remove the square root symbol, it turns that 64 into an 8. Now, the second thing we had to look for is implied operations. Are there any here? Yes. There's that 3 that's in front of the square root with no operation there. That is implied to be multiplication. So now that enclosing symbol is gone. That actually takes care of our enclosing symbol and our exponent all at once. So now, no other enclosing symbols, no other exponents. We're down to multiplication and division. Which do we do first? Yeah, we got to go left to right. Multiplication and division happen at the same level, so we go left to right. 28 divided by 4 is 7, good. And then, of course, we have the 3 divided by, or 3 times 8, which is 24. And finally, 7 minus 24. You can treat that as 7 plus a negative 24 if you want to. Positive 7, negative 24. We're negative, and the difference between them is 17. What do you think? Better than a sharp stick in the eye? Okay. Well, we could also have something like this. Looking at this problem here, first thing we have to figure out is what does this line across here mean? Division is what most people go to first, and it does mean division. It's called a fraction bar. It does mean division, but it is also an enclosing symbol. It separates part of the problem from the rest of it. It is telling us that we have to do everything on top first, then we have to do everything on bottom. Then we can divide those results. So on top, I'm going to write it off to the side here so I have room to do it. Any other enclosing symbols on top? Nope. Exponents? Nope. What do we have to do first? Well, no, we got to do the top first. So we got the 35 divided by 5 is 7. Then we would do multiplication. 3 times 7 is 21. And then 7 plus 21 is 28. It is kind of confusing because you see this exponent down here and you want to go to that first. But remember, this is an enclosing symbol. It separates the top from the bottom. It's just like having parentheses around them. So you got to do what's in the first set of parentheses first. It's almost two separate problems that are combined together in the end. So then on bottom here, what do we have to do first? The squared. I knew what you meant. 3 squared is 3 times 3 or 9. Perfect. And then 16 divided by 8 is 2. So 9 minus 2 is 7. So the bottom is 7. So we have 28 divided by 7, which is 4. Any questions? Okay. So these order of operations, of course, apply to any type of problem, but I've tried to keep them positive for the most part so far. But we can have our integers in there as well. I don't want to do that to you quite yet. I'll be nice. So doing something like this, where do I start? Now see the parentheses here. There's a parentheses inside there. Does that parentheses mean anything? No, it's not. In this case, that inner parentheses is not an enclosing symbol. It's not telling us we have to go inside there first. It's just separating that -2. So we know it's a -2. So we're really working inside the bigger parentheses in the green box. What do we have to do first? Any other enclosing symbols? Nope. Exponents? Nope. Multiplication and division? Yeah. 4 times 3 is 12. Next we have the 6 times -2, which is -12. Again, I'm going to put it in parentheses just so we know that that's a -12. Now we're still inside that big set of parentheses. All that's left is addition or subtraction. So we're going to work left to right. So we've got -5 minus 12. A lot of times what I want to do is I'm going to write that off to the side, -5 minus 12. So I can work with that by itself and not have to worry about the rest of the problem. Now, of course, -5 minus 12 becomes -5 plus the opposite. What's the opposite of 12? -12. So it's -5 plus -12. -5, -12 point the same direction. So that result is negative. What just popped up there, by the way, if you're ever working on a computer at WITC and that pops up, that is our severe weather alert system. They're testing it today. It must be 10 o'clock. Yep. So they're just testing it today. There's not any severe weather coming, just so you know. So anyway, the -5 plus -12 or -5 minus 12 is -17. And we now have -17 plus, let's see, that line's disappearing on me. Some of your cell phones might be going off too, by the way, if you have the alert system set up. We now have the -17 plus -12, which is -29. Now, everything inside that parentheses has been reduced to a single number. So we don't need the parentheses, but since it's a -29, we're going to leave them there anyway, and we're going to put in that implied multiplication. So now we have 3 times the -29, which is a -87. We're left with -8 plus -87. They're both negative. They go the same direction, so the result is negative. Since they go the same direction, we combine the values. 8 plus 87 is 95. So there's all sorts of fun we can have. Okay, since we've got a few minutes here left, I want to go over a couple of little things on estimating. I made a big deal over the last couple of days about estimating before you punch numbers into the calculator. I'm going to talk about mostly larger numbers today. And we did a little bit of this. We talked about it just briefly on Monday. But if I have things like 392 plus 621, before I punch that in the calculator, I'm going to round these to the simplest way I can, which is basically just the first digit. 392 is close to 400. 621 is close to 600. Now I go to combine those. 4 and 6 make 10. Now hundreds and hundreds stayed hundreds. Well, rather than worrying about that place value and talking about the names, the shortcut is simply this. If you have the columns lined up, you can just bring down the zeros and add the whole numbers, as long as the whole numbers are in the same column or same place value. So if I had 30,000 plus 50,000, are the 3 and the 5 in the same place value? Yes. So I can just combine them. 3 and 5 make 8. And we keep the same number of zeros after them. That's keeping the same name. If I have 2,000 plus 900, are the 2 and the 9 in the same place value? No, they're not. So all we do, usually easiest to line them up, is we keep those 2 digits in their place value. The 2 is in the thousands place, the 9 is in the hundreds place, and we fill in the other place values. To estimate with subtraction, it's very similar, maybe just a touch more difficult. We might have something like 500 minus 200. Are the 5 and the 2 in the same place value? Yes. 5 minus 2 is 3, and they each have 2 zeros, so we keep the 2 zeros. We're keeping the same name. We might have, however, an estimate where we have 3,000 minus 700. Are the 3 and the 7 in the same place value? No, they're not. So again, it's usually easiest to line them up. We've got the 2 zeros, that coincide, so you just bring them down. But now I'm going to take 30 minus 7 to make 23. So that's where the subtraction can be just a touch more difficult than the addition. Multiplication. Remember, when we multiply, we don't need the same name, so we don't need the digits in the same place value. And then we also combine the names. So rather than just keeping the same zeros, we're going to have to combine the zeros. For example, 3,000 times 200. The 3 and the 2 are not in the same place value, but it doesn't matter. We're going to do 3 times 2 is 6. If we were looking at the names, thousands times hundreds would be hundred thousands. The shortcut is to just combine. We have 3 zeros and 2 more zeros. That's a total of 5 zeros. We might have 70 times 300,000. Well, 7 times 3 is 21. We have 1, 2, 3, 4, 5, 6 zeros total. So that becomes 21 million. One that can be a little trickier might be this one. 800 times 50,000. What is 8 times 5? What 8 times 5, I should say, is 40. Then I have 1, 2, 3, 4, 5, 6 zeros. So do I go 1, 2, 3, 4, 5, 6? Does that work? No, that 1 was part of the 40, which was from the 8 and the 5. I have to do 6 more zeros after that. That's 40 million. So you have to be careful if your multiplication ends up with a 0 in it as well. And the division, again, we do not need to have the same name, so we don't care if they're in the same place value. We just divide. 8 divided by 2 is 4. Now dividing, instead of combining zeros, we cancel zeros. We're dividing by a number with 1 0, so remove 1 0 here, and we're left with 2 zeros. Even if there is more than one digit here, we might have 240,000 divided by 300. What's 24 divided by 3? 8. We have 2 zeros here. We cancel out 2 zeros there. We're left with 2 zeros. A little more difficult might be something like this. $70,000 divided by 5. The 7 does not divide by 5 evenly. But we can do this. We can take the 0 with it. Does 70 divide by 5? Yes, it does. 70 divided by 5 is 14. We cancel out 2 zeros and 2 zeros. That one was already used, so all we have left is 1 more 0. It's 140. Now again, it's not something I'm going to specifically ask you to do, but as you're doing these estimates, it's a skill that's good to have. Anybody have any questions on the stuff we've covered this week? Okay. Has everybody been able to sign up for my math lab? Anybody has not made it yet? You're still waiting on a code? Okay. So there's no new assignment today. It's just still working on that homework number 1 that we assigned yesterday. Has anybody started that and have any questions on it they want to go over quick? You finished it? Okay. Yeah, that one's okay. That one's not too bad once you get going on it. It's maybe just getting used to the system is the big part, and how you enter fractions and stuff like that. Okay, well, that is all of our material for this week. So it doesn't happen very often, but I'll let you out of here 10 minutes early today. The quiz will not be until Monday. Thursday, there's never any new assignments on a Thursday. Thursday is always just our day to finish up anything that I didn't get to, and to review and answer questions on the week. So new assignments always start on a Monday or a Wednesday, new homeworks. Quizzes then are always the next day. So there might be quizzes on a Tuesday. Well, it'd be starting Monday going through a Tuesday, or starting on a Wednesday going through a Thursday. So next week there'll be a quiz on Thursday, but that'll be the one that's assigned on Wednesday's class. Does that make sense? The schedule normally will look like this. You've got Monday, Tuesday, Wednesday, Thursday, Friday. So you'll have a homework that starts on Monday and goes to Wednesday. Then on Wednesday, you'll have a quiz that starts on Wednesday and goes through the end of Thursday. And you'll have a new homework that starts on Wednesday and goes till the following Monday. I'll just call that homework 2, homework 1 for now. Then on Monday, there'll be a quiz that starts Monday and goes through Tuesday. That'll be quiz on the homework 2 stuff. And yep. Okay. So yeah, your first quiz won't be until Monday. Any other questions? Okay. Well, we'll see you guys on Monday. Have a great weekend. If anything pops up with my math lab, please let me know. Or anything else for that matter.